See Vlasov's book, Non-Local Statistical Mechanics. And charge carriers cooperate in the sheath of the Scholl coaxial. As for the first approximation, only the distribution of concentration of charge carried along the ELF radius must be defined. The model of an ELF is given in the illustration. Therefore, the dependence on generalized coordinate r, which can provide the solution for monotonous charge density vertical profile from troposphere to ionosphere distribution, is excluded from Gibbs-Vlasov canonical distribution and Gibbs-Vlasov non-local statistical distribution function. The dependence on generalized momentum p, which can provide the solution for the charge-velocity distribution of their chaotic motion in the undisturbed sector across the troposphere-ionosphere, is also excluded. Thus the simplest case follows. In the formula O203, the dependence on the generalized moment of momentum, where L is generalized angular momentum, means that it is postulated that such non-local statistical cooperation between charge carriers results in a ring structure self-organized by charges. Such a self-organized ring structure is clearly observed and appears to last until external energy comes into the open system, troposphere, ionosphere, space. In other words, external energy comes into the open system until impulse potential difference is applied to the plates of a flat capacitor. To obtain an analytical solution, the first equation of the Vlasov-Maxwell set is used in the form and can provide the shapes of sections of equal halves taking place above and below the horizontal plane of symmetry of ELVs, see the illustration, concentrating distribution of charge carriers along the horizontal radius of ELF. Here VR, Hamilton vector operator of radius vector r of charge carrier m, average mass of charge v, Hamilton vector operator of velocity vector v of charge. Potential energy of charge system, see Vlasov's book Non-Local Statistical Mechanics. Here K, energy of non-local statistical interactions between any two charges, r, radius vector of test probe charge relative to the center of the ELF, the vertical axis of which is established from its center. The illustration represents a vertical axis becoming coincident with the central filament of the ELF. R, radius vectors of all the others' charges, the number of which could not be measured. For the first approximation, Vlasov's non-local statistical distribution function can be represented in its simplest form. See Vlasov's book Non-Local Statistical Mechanics. Here R, the shortest route from the central axis of the ELF towards the one of a charge, v psi, vortex component of velocity vector of a charge, I, angle between radius vector of charge and horizontal plane of the symmetry of an ELF. For the first approximation, the solution of the first Vlasov-Maxwell equation can be found in exponential form. See Vlasov's book Non-Local Statistical Mechanics, where J equals RV psi sine I. Let's consider the simplest case of a circular section of toroid, which is self-organized by charges, that is, ELF phenomena. Constant coefficients for such simplest case are taken in the form here psi, angular velocity of macroscopic vortical disturbance within non-local statistical disturbance function of charges, theta, statistical, the second one, see Vlasov's book Non-Local Statistical Mechanics, temperature of charges, A equals constant. The desired solution was called the Vlasov-ELF solution and taken as function VE. This solution is represented in the form of two exponent products. Here C is the constant of integration. It is appropriate to explore the qualitatively obtained solution function VE of non-local statistical distribution function of charges filling up the volume across the plates of the flat capacitor, represented as troposphere-ionosphere. As is known, the product of a quadratic velocity function and an exponential velocity function is represented by an asymmetric bell shape, that is Maxwell distribution function. One can substantially assume that the cross-section of either half of the toroidal distribution function of self-organized charges, in other words, the ELF described as the product of two exponents, will have the same bell-shaped form, but a more symmetric one. It is also appropriate to explore the analytically obtained solution function VE. Solution function VE transforms the central axis of ELF. If R leads to 0, one may be easily convinced of this obtained expression. It is not hard to conclude that in such cases the exponent turns into the expression containing total charge energy in the volume across the plates of the flat capacitor, which is represented as troposphere-ionosphere, where potential energy, WP, equals U, and kinetic energy. If the total energy is concentrated on the central axis of the ELF, that concentration of charges may be estimated. This is only possible only in the case if self-organization of the central filament of the ELF appears to be in a state of limit excitation of the flat capacitor troposphere-ionosphere. In other words, if W leads to infinity. For the present instance, function VE leads to 0, and therefore N leads to 0. Thus, in a limited case, the least concentration of charges which have the largest velocity or energy will be on the central axis of the ELF. It should be pointed out that there are no other mathematical modeling techniques save the set of Lassov-Maxwell equations used in the frame of conception of non-local statistical cooperation, which provides accurate solutions to the problem of self-organization of toroid with central filament or cable appearing to be in the open system. The medium, open system, is supplied by energy per pulse. Such input energy is simulated as impulse potential difference, which is applied to the plates of the flat capacitor represented by troposphere-ionosphere. Conceptions of impulse self-organization of proton structures that couple across troposphere-ionosphere, the gigantic electrical circuit, Sun, IMFL, Earth, IMFL, heliopause, IMFL, Sun, which generates pulses of extra EMF, was the cause of these high-altitude impulse glows, such as Sprites, elves, jets. These conceptions have allowed an explanation in the most natural manner of the discussed phenomena as the effects of impulse self-organization of proton structures across troposphere and ionosphere. It should be pointed out that the brightest line of radiation of atomic hydrogen, H-alpha, is red, and the spectral line is a wavelength of lambda approximately 656.28 nanometers. Therefore, the sub-horizontal ring of blood-red ELF is the result of non-local statistical cooperation, occurring between hydrogen atoms which are excited by a process of self-organization of subvertical proton structure. Thus there is impulse charge exchange above the troposphere, due to moving toward the ionosphere of such so-called phenomena as goblins, blue jets, red fairies, pixies, gnomes, elves, which are observed when lightning appears in the troposphere. However, the time scale of high-altitude phenomena is much less than tropospheric discharges by several degrees of magnitude. The question asked is why lightning, visible, and thunder, thundering, the most often at the middle latitudes in summertime, but are rarest in winter. Matter is of the essence. Water is in the form of molecules, dimmers, trimmers, tetramers, and multimers in summertime in the lower troposphere at middle latitude. However, water is in the form of ice crystals in winter. When the properties of fairies, goblins, pixies, gnomes, elves are being discussed, a similar question arises. What is the role of H2O molecules and their associations, dimers, trimers, tetramers, multimers, in the impulse self-organization of proton structures across the troposphere and ionosphere? Here is an example from recent research, EuroSprite 2009 to 2011, Observations of High-Altitude Phenomena. Average Seasonal Transient Luminous Events, TLE, cycle above Europe in 2009, 2010, 2011, showing the maximum numbers of TLEs during November months. In the framework of cosmic meteotectonics, such correlation can be connected with galaxy helio-geotectonic coordinate system, i.e. orbiton time. The basis of GHGT coordinate system is the diameter of the Earth's galaxy tecton orbit, crossing orbital points through the center of the Sun. Unfortunately, the lack of data on seasonal movement of high-altitude phenomena and its irregular distribution along latitude and longitude around the globe prevents even a preliminary conclusion about the participation of H2O molecules and their associations, dimers, trimers, tetramers, multimers, in the impulse self-organization of proton structures across the troposphere and ionosphere. The investigation is at the beginning, but it has led to preliminary conclusions about esoteric phenomena and origins. As, for example, the lifetime of such glows is less than the lifetime of tropospheric lightning glows by 10 to the 4 to 10 to the 6 times. Therefore, if one assumes that long-lasting discharges in the troposphere are the reason for the origin of ultra-short discharges in the stratosphere and mesosphere, it does not hold water. A significantly higher probability is that ultra-short glows in the middle atmosphere are associated with impulse currents which appear to be within self-organizing structures, in other words, in subvertical wires, which are impulse self-organizing and linked to layers of the Earth, troposphere, and ionosphere. It should be pointed out that cosmic meteotectonic correlations, which were being confirmed manifold within the 20th century, have stimulated in due course the development of an electrical network model of subvertical charge exchange across the magnetosphere and the Earth's core. Cooperative, or in other words collective, non-local statistical, properties of H+ and OH- condensates provide impulse self-organization of sequences, which can be described as alternated subvertical and subhorizontal objects, consisting of proton and hydroxide ions. At this point, OH- condensate is the analog of crystalline lattice, the parameters of which are calculated in the frame of a non-local statistical model of crystal. See Vlasov's book, Non-Local Statistical Mechanics, and Vlasov's paper, Thread-like and Plate-like Structures in Crystals and Liquids, and the H+ condensate, represented as atomic nuclei ions, which are comparatively more mobile than molecular ions, OH-, and that's the analog of electrons, vacancies, condensate. Research papers by Kuznetsov have been led to massive investigations of pulse structures occurring in the form of bead lightnings. These clarified that the relation of the beads, or plates, thickness and length, which are connecting plate-like structures, vary from lightning to lightning, and moreover along a single lightning branch. By analogy, using electrical network simulation, it is assumed that proton and hydroxide ion structures are being impulse self-organized to exchange between or across thicknesses of hydrogen plate-like structures and lengths of hydrogen thread-like structures. By analogy, using electrical network simulation, it is assumed that proton and hydroxide ion structures are being impulse self-organized to exchange between or across thicknesses of hydrogen plate-like structures and lengths of hydrogen thread-like structures. In this case, hydrogen plates are proton and hydroxide ions, lenses, plates and platelets, flakes, charges between or across geospheres and its subparts and layers, which have different capacitor relation. Hydrogen threads are proton and hydroxide ions channels, shafts and wires. Electrical network simulation takes the time between impulse self-organizations of such proton and hydroxide ion structures and lies within the wide interval from 10 to the power of -5 seconds to the period of solar spot activity. Thus, the proton and hydroxide ion structures of each of geosphere represents ensembles of sub-horizontal plates, lenses, platelets, flakes, beads, interconnected with ensembles of subvertical threads, channels, shafts, wires. See Vlasov's book Non-Local Statistical Mechanics, 1978 in Russian, and Vlasov's paper Thread-like and Plate-like Structures in Crystals and Liquids, 1970 in English, in Journal Theoretical and Mathematical Physics, to explore the exact solution of self-organization of balls, spheres, cylinders, and toroids, as well as plate-like and thread-like structures. It should be noted that only Vlasov's models of non-local statistical mechanics will be of help to investigators who explore high-altitude phenomena and employ esoteric names to convey the real meaning of every unreal sound: goblins, fairies, pixies, gnomes, and elves.